Thank you.
Okay. I guess just those for the stream. The topic today is going to be REST, SQL, APIs, and CPG at MIT. So we're going to talk about data retrieval and manipulation for CPG software. And we're going to go over what all of those acronyms mean. Some of them may be familiar, others unfamiliar. But my goal for today is really to have a chance to talk with you guys a little bit about what Vividly does for business, how we use web technology and the things that you're learning these few weeks in web lab, how we can look at that in a real world scenario in solving business problems, and give you some insights into some potentially new technologies that you might not have seen before. So we're going to start off with what is CPG, what does it stand for, and who are we, what is Vividly? And then we're going to look a little bit deeper into a CPG scenario. We're going to take a quick example of a very representative problem that we're solving as a business. And then we're going to talk a little bit about REST, which may be a review for some of you. I know in web lab recently we've been talking about node servers and API design. And then we're going to talk about a technology called GraphQL, which is really a bit of a paradigm shift and something that is going to lead to some interesting discussions about how we use that in CPG and at Vividly. And then finally, I have a few small demos of how we can use this technology and what it looks like in action. And I definitely want to say, please stop me if there's anything I can repeat or explain in a different way, ask questions at any time. I'll be looking out for your hands. Okay. So CPG stands for consumer packaged goods. So if you're comfortable and able, I'd love for all of us in the room to stand up for a second. Okay, thanks everyone. So what we're going to do first is I'm going to show a couple of logos and just take a seat if you've either seen it at a grocery store or online anywhere that you shop. Or even better, if you've had it before, if you bought it before, if you enjoy it. So we're going to start off with Perfect Snacks. Okay, a couple of you. Oatly. Okay, I got a bunch of you there. Our favorite dairy milk alternatives. Amy's. Oh, a couple of you. Lesser Evil. I don't think anybody with that. Super great low calorie popcorn if that's your jam. Hint Water. Wild Planet Foods. Banana. Okay, and then any of these if you see them. All right. Feel free to take a seat. Thanks for educating that. So a couple of you guys left standing. I guess the punchline here is there's a bunch more brands that we work with, but these are going to be some of our clients, some of the people that use Vividly to help run their business. So obviously some of them very well-known brands, others sort of more niche, more specialty, but this kind of gives you an idea of what industry you work in. So all of these brands are working in CPG or consumer packaged goods. So I want to give you guys a CPG overview and explain really what it is the business problem that you're addressing and the one that we're using web technologies to solve. So as you may know, when you're in a grocery store, every brand in the store at some point in the season, maybe it's even online or in retailers like Whole Foods or Target, are running hundreds or thousands potentially of discounts as promotions on their products every year. And across the industry, most of them are tracked in spreadsheets. So you can kind of see the spreadsheet sequence of being here, which I think most of us, definitely myself, have experienced. So you have a sequence of documents, these spreadsheets that potentially have complicated business logic embedded within, but they're different from each other and you can lose track of what's going on, and you can't see the relationship between all of these entities. So some of the questions that these businesses have to ask themselves are which and how many products are going to go into promotion. So your favorite brands, like if you like the chocolate or the vanilla or the creamer or any of their products, when should those go into promotion and where? There's certainly seasonal aspect of things and lots of other things, lots of other metrics to consider. Another question is, what is the size and type of the promotion? So are we going to do a vote, a buy one get one, or are we going to have coupons in the mail, or are we going to give 20% discounts at the point of sale at checkout at the grocery store? What is the size and type? Which stores will run the promotion? So a lot of these brands have dozens, maybe even hundreds of customers or retailers that they sell to. And which of these stores is going to run the promotions is an important question that you have to ask when you're doing promotion planning. And finally, as a final example, when will the promotion get run? What time of year? How often will it be? Weekly, monthly, seasonal? And when will it get canceled? So we can replace these spreadsheets and views with Vivid. And hopefully, in the next couple of slides, we can talk about how we use our technology to solve the problem for our clients. So I want to give you guys an idea of what the three most important entities in CPG are in the context of Vividly and our software. So those are the customers. For example, Target, Kroger, Albertsons, Unify. So these customers are essentially the customers that our clients, these brands, are selling to. So these would be your retailers, your distribution channels, and so forth. Next would be the products. What is it that they sell? Is it oat milk? Is it flavored water, popcorn, you name it. And then finally, what are the promotions? What is the promotion type? What are the details of that promotion? What stores are those promotions linked to, and so forth. Can I get a hand on who knows what ERD stands? Anybody? What was it? I think, did you say entity relationship diagram? Okay. Okay. You still get to vividly have for putting yourself out there, so. So ERD stands for entity relationship diagram, and I don't want to talk too much, too deep into database design. I think actually a great thought you can refer to for that is one that Daniel gave us at lab in 2022 on database design. But this hopefully gives you an idea of how these data entities are related. So you have your customers, and each customer has a unique identifier that the data type is a string, a name, and then these relationships with these other data entities. So it has products that are associated, and it has promotions that are associated. And likewise, the product model has promotions that are associated with the product, and so forth. So hopefully this gives you an idea of how intertwined all of the data that you're working with can be. But just to take a step back, it's worth mentioning that just by way of analogy, the example we're going to look at today is kind of like the local host 3000. And in the real world, it gets a lot messier, a lot more complex, and a lot more data, and more sophisticated logic. Okay, so let's look at a CPG scenario. So let's say we have WebLab coming, and WebLab would like to use Vividly to streamline their trade promotion information. So I think we've unlocked another acronym here, which is TPM, which means trade promotion management and encapsulates the entire process of promotion planning your promotions on your products with your customers, and that encapsulates that entire process. So WebLab sells to several hundreds of customers nationwide or even internationally. They offer several dozen unique product offerings, and they conduct regular promotion monitoring. So even if you think back to the ERP from the previous slide, you can start to imagine how WebLab has a lot of complex business logic that involves multiple channels for reaching customers, customized and granular promotional activity, and dozens of seasonal products. Okay, so now let's try to imagine if we're Vividly and we want to help WebLab do their trade promotion management, do their TPM. What are some of the different data views that we want to have? One example would be looking at a list of customers, accessing the IDs of our customer list. And one potential application of this could be, let's say you want to integrate some of this data with another system. You want to have access to a unique identifier for all of your customers. Another example is accessing a separate data model. So instead of the customers, we want to do the same thing with our products. What if we want to look at the relationship between the two? So as we saw, each customer has, we use a little bit of database jargon, of one-to-many relationship with product. So each customer has a relationship with several other instantiations of the products. And what if we want to look at that? And we want to access that data. Finally, what if we want to look at a different field? We don't want the IDs, we want to look at, for example, the name. And as I said, you can imagine there's so many more fields with properties for our data models than in this example. But let's say we want to access, and I think there's one more actually. What if we want to look at multiple, and we want to retrieve multiple different fields for each of our promotions, which once again is another data model that we have in this example. Okay, so I want to ask you all what ideas you have about things that are important to consider when deciding how you want to fetch your data. Given this example, the types of things we want to see, and the relationship between the customer promotion and the product. So really feel free to just give all some ideas. What are some things that are important? Yes. So what was your name? William. Oh, great. William said, "What might be changing?" So that's a great point. So my interpretation of that is potentially how the data models might be, the relationship between one another might be changing, or potentially the models themselves, adding more fields, things like that. That's totally right. Any other ideas? Yeah, so actually just work with that. What was your name? Raphael says the amount of data and thinking about optimizations on how to quickly go through the quantity of data that you have. That's also super correct, and we'll also talk about that as well. Maybe what happens. Any other ideas? Yeah. How the data is what? Related. Yeah, exactly right. So, what was your name? Wait. So Quinn says how the data is related. So that's exactly right too. So the relationship between the data is going to have a really, as we'll see, a really important effect on how we think about how we want to fetch the data and how we want to move. Yeah, I think I have one more. Any last ideas? How often we're trying to access? Yeah, what was your name? Claire. So Claire said how often we want to access the data, and that's also exactly right. So we want to think about what type of data we're accessing and when, with what frequency. That's also going to be super important. So I have my answers to this question on the next slide. And you guys, I think, probably covered like all of them, which I think is incredible. So here are the things that we should be thinking about. We talked about adaptability. So how often our data is changing. And we talked about performance. Thinking about optimizations and how we're going to access our data. If we have large quantities, which in the case of CPG, in the case of Vividly, we definitely do. Another thing is over and under fetching refers to what data you're retrieving and the shape of the data that you're pulling from your server, which we'll see in GraphQL and REST. Resource endpoints refers to where the resources are in the server, how to access them by the network. And finally, development speed is something that's important to keep in mind kind of throughout all of this is you want to consider all of the stakeholders, the people using your software and also the people building your software. So as you think about API design and the decisions that you have to make, you want to think about both of those parts. So hopefully you'll see that there are differences in the experience that you have as a developer and as somebody who's going to be building and improving the software. Okay, so just by way of a little bit of review, I know in WebLab you guys have the staff have done an amazing job covering REST and using Node and Express to build that. I just want to do a quick review just to highlight some of the important concepts that are related to what we want to talk about today. So here's just like a fun graphic showing the duality between the client and the server. So ultimately you have your different types of requests that you can make in the client side, get requests, post requests, and so forth. And you have your database where your data is going to be served up via your REST API. So something important to highlight here is that I think a lot of you have had some experience writing some endpoints of your own. The server is really what is controlling the data, the shape of the data that is getting returned to the client. The client is making a request to a particular URL endpoint, and that data is coming back as potentially a JSON, some other data format that is controlled by the endpoint that you move it. So I like to talk about this by way of analogy. So I know that WebLab has been using a state analogy for some of the React state management concepts that we've been talking about. So I'll try to do another state analogy. So REST APIs are kind of like ordering off of the menu. So if I order steak off the menu, I think that you know, I want the steak, but it's possible that it comes with, you know, a side of Brussels sprouts or some potatoes or something to go along with it. And maybe I don't really like Brussels sprouts, or I don't have the appetite for it, but it kind of comes with it anyway, so can't really do anything about it. So that would kind of be an example of overfetching. So this happens a lot in REST API design, where you've implemented these endpoints, and on the client side, you make call to this endpoint, but it gives you a bunch of data that you don't really need. Maybe we want to get the customer IDs, but it also gives us their names, it gives us their promotions, it gives us all this data that we don't need. On the other side, on the other hand, if let's say I order the steak and I also want to get a drink, but in order to do that, I probably have to order off of a different menu. And maybe there's a different drink menu, and maybe the person making my drink is the bartender, or a different person is preparing that for me. And that's kind of like making it the API request to another endpoint, another URL. And that other endpoint is going to have its own implementation on the server side when you make that API request right now. So GraphQL is different because GraphQL gives the client control of the shape of the data that's coming back from the server. So the analogy that I'll try to use here is custom made. So custom made is a custom merge ordering service that hopefully many of you have heard of. And they really give you the control of what you end up with. They let you implement your own designs, choose the colors, choose the brand, choose the type of whether you want a polo or a t-shirt or pants, anything. You can also control sizing, and you really get back from them what you put in. So the way that looks in GraphQL is you're making requests to the GraphQL endpoint and requesting certain data, certain fields in a certain way. And it comes back to you in the same shape. So another key difference, going back to the considerations that we outlined, is that GraphQL only has one resource endpoint. So instead of hitting multiple endpoints for different parts of your data model, or your different parts of your data models, you're hitting one endpoint that's able to actually traverse your database schema and give you back the data in the shape that you requested. So let's go over each of these considerations in the context of vividly and see how we did it. So from a data fetching standpoint, REST APIs are going to struggle a lot with over and under fetching. And for vividly, when we have all of these different data views that we saw in the slides, we're going to be making requests to resource endpoints that are giving us tons of information that we either don't need for that particular view, or we're going to have to make several requests to get everything that we need for that particular view. So unfortunately, data fetching has some downsides with the REST design. As I said, resource endpoints, there's going to be many. And for your complicated data model, and in the case of CPG, and vividly, that's potentially going to affect your performance, affect a lot of things downstream. So unfortunately, we have a sad piece there as well. Okay, so for development speed and ease. So with a system that has a lot of interconnected data models, using a REST API design, which requires you to write endpoints for every particular view that you want to implement, or requires you to over or under fetch with your existing endpoints, there's a level of rigidity that really can affect your development speed. And as previous speaker said, having a good session, developer time is really valuable. And we also want to have a good developer experience. So Unfortunately, the REST design in Vivid space is not going to be the best choice. And as William said here, we're concerned about adaptability as well. And what if our data models are going to change? What if their relationships are going to change over time? We need to introduce new models and things like that. So this rigidity with writing endpoints in your server is also not going to be the best choice. And finally, as far as performance goes, which is related to a lot of these other ideas together, when you're making all of these sample requests, you're not getting the data exactly as you would like it. That can really affect the performance. Okay. So in the case of GraphQL, we can have our data come back to us in a custom shape. We're only accessing one resource endpoint instead of having multiple URLs, slash customers, slash products, slash conversions, and so forth. As you'll see in the demo we'll do in a second, you have a lot of client-side control on what the data is going to look like when you request it. GraphQL offers a flexible schema. So the reason why, a little bit about the etymology of GraphQL, the reason why it's called QL stands for query language, and you can really think of your data model as a graph of interconnected entities. And what GraphQL is doing is actually traversing those data models to get the fields that you request in the shape that you request them. And finally, from a performance perspective, GraphQL does suffer from something called the N+1 problem, which is something that you might have heard, you'll hear about when it comes to API and database design, which basically is an implementation problem that involves querying N+1 times. Let's say you want to query for all of the products that are associated with all of your customers. So you may have to make one query for the list of customers and then 10 more queries to get the set of products for each of those customers. So this is something that can happen with GraphQL. However, there is something called a data loader, which is an implementation layer that is going to actually help you load some of your data so that you can avoid this problem. So we can actually turn that around upside down and solve that problem. Okay, so let's look at a couple of examples of these two systems. Okay. So what I've done is I've spun up two endpoints locally, and we can look at what a REST API will do, which I believe is at port 2000, and what a GraphQL API is able to do. So let's go back to this slide of all of the views that we want to create. So let's say we want all the customers. So in order to do that, you need to implement an endpoint to get your customers, which I've gone ahead and done. And this might be a familiar view to you. You get some type of JSON object with all of your data. But the problem is, if we fetch all the customers like this, we actually get a bunch of data that we don't need, and we can parse it on the front end, we can ignore it. This is a standard experience for REST API development. So let's say we want all of our products. So we have an endpoint for products as well. And once again, you have the IDs, all your products, steak, pasta, marinara, basil, all of your different stores. Again, a bunch of data you don't really need, and you can parse it on the front end, or find a way to interpret this response from the server. And, once again, we can look at promotions. And, if we want to explore the relationship between the customers and the products, we can go back to our customers and we can parse, where are the products in this server response, implement some logic so that we can pull out what we want. But let's say, if we really want just the IDs, we can implement another endpoint that's going to give you the IDs. But once again, you have to, implement another endpoint for every other thing that you need. So now let's take a look at what GraphQL is going to offer us. So here is a GraphQL endpoint. The backend is serving the same data that we saw in the REST example. But when you build a GraphQL endpoint, you actually see all of you get this interface that actually will help you write your queries so that and give you examples of what data is going to come back from the server. So let's say we want the customers. All we need to do here is we have our customers, and then we can get the IDs, and voila, the data comes back in the same shape that you requested it. Let's say we want our product IDs. Voila, there you go. Let's say we want to explore this relationship. So let's query for customers and then look for products. And then let's say we want their names. And let's say we want to look at everything all at once. Another nifty thing to notice here is based on your schema definition, this interface will actually also show you what you've defined, the queries that you've defined and what their associated fields are. I'm gonna just switch back our Zoom attendees to the right screen. Great. So just to tie a knot on some of these ideas, when you're designing your web application or anytime you're using web technology, it's important to consider the pros and cons and trade-offs of how you fetch and manipulate your data based on what your data model looks like, what the relationship between them looks like, and what you're trying to accomplish. So I would encourage you in your projects or web lab, think about what your data is going to look like. Think about whether you can leverage GraphQL, whether it's going to help you from both a developer and user standpoint, reach your goals faster, more efficiently, more elegantly. And understand that there are use cases for both options, and kind of how did we as business come to the conclusion that we want to use one thing over the other, and how powerful it is to go through that decision-making process of deciding what technology you want to use. And finally, if you want to learn more, you're interested in what we do, and just want to talk more about any of this, feel free to get in touch with any of the three of us. And we also are hiring as well. So thank you so much for the time. This is a lot of fun for me. I hope this was interesting for you as well. Feel free to ask any questions, by the way. Any questions about the content. I guess one other thing, I'll use the mic. Oh, yes.
Yeah, I guess one thing I'd like to mention is that like the talk isn't a message to not use REST. So there are a lot of applications of REST, but the thing that I guess the point of what we talked about is that admittedly, because our data models are what they are and the industry, like consumer packaged goods, CPG industry is what it is. GraphQL was the better choice for us in terms of how we were querying data from our front end to our back end. So just as a kind of clarification / information type. Any questions from anybody or any of us? I think we have one more slide item. Yeah.
I'll give you the microphone.
Just wanted to ask what your API endpoint looks like. You said you just have one with GraphQL.
Yeah, exactly. That's exactly right. So when you're using a GraphQL API, all of your resources can be accessed by one URL endpoint. So for example, when we were looking at that demo, the endpoint, instead of hitting different endpoints like /customers, /products, and so forth, you're actually hitting /GraphQL. And then by that entry point, you're able to traverse your data model via that query that you put in. Anything else from anybody?
Cool. All right, thanks everyone.